The power rule. The power rule is a nice rule because it applies to a lot of different functions. It applies to any function that looks like x to the n as long as the exponent n is constant. The rule says to take the derivative of this function, all you have to do is identify the exponent n and write n times x to the n minus 1. The power rule is derived using the limit definition of the derivative. That is, one starts with the limit definition of the derivative, puts in f of x equals x to the n, and somehow through some process eventually arrives at this rule. We won't go through the derivation in this video, but you need to remember that this rule, like all rules, gets derived from a starting point of using the limit definition of the derivative. This rule is completely consistent with the examples that we saw earlier. We remembered a specific rule for x squared. We can also use the power rule to get that same formula. We just have to identify that the exponent in this case is n equals 2. We need n minus 1 in the formula, so we find n minus 1 is 1. We put 2 and 1 in for n and n minus 1 into our formula, and we see that f prime of x is 2 times x to the 1, which of course is the same as 2x. So that means that the rule that we remembered earlier, f of x equals x squared, means that f prime of x is equal to 2x, is a special case of this more general power rule. Same thing with f of x equals x. To use the power rule on this, we write this as x to the 1. We identify that n equals 1, so n minus 1 equals 0. We take 1 and 0, put them into the formula for the derivative. F prime of x is equal to 1 times x to the 0. And in this case, we can interpret x to the 0 as just 1, so the answer is just 1. So that rule we learned before that said that if f of x equals x, f prime of x is equal to 1, is again a special case of the power rule. Let's look at a case that we haven't seen before. Let's look at x to the minus 4. In this case, it's easy to identify n. We say n equals minus 4. So the power rule says just compute n minus 1. n minus 1 is minus 5. Minus 4 minus 1 is minus 5. So we use minus 4 and minus 5 in the power rule, and we find out that f prime of x is equal to minus 4 x to the minus 5. That's the power rule. It was very fast to compute this derivative of x to the minus 4. Let's look at a little bit more complicated case. Let's look at the square root of x over x cubed. In this case, to apply the power rule, we first have to rewrite this expression as x to a single exponent. So we need to do some simplification before we apply this rule to find the derivative. To do that, we remember that the square root of x is x to the 1/2, and so this expression is x to the 1/2 divided by x cubed. To simplify that further, we remember that in this case we subtract exponents, so it's x to the 1/2 minus 3. Simplifying the 1/2 minus 3, we find this is x to the minus 5/2. So now this is in the form of the general power rule, and we can identify that n is going to be this exponent, minus 5/2. So we also need to find n minus 1. n minus 1 is minus 7/2. And we can put minus 5/2 and minus 7/2 into our formula to find out that f prime of x is equal to minus 5/2 x to the minus 7/2. Or, using rules of exponents, we can rewrite that with square roots as writing it as minus 5 over 2 square root x to the 7th. This is an example of using the power rule. It's a very powerful rule because it applies to lots of different functions, and it makes it very fast to find the derivatives of those functions. In fact, when you get good at this, you don't write down any intermediate steps like this at all. You just go from the function immediately to the derivative.